This video will cover beginner part 2 questions regarding the topic of curve sketching. Number 1, let y equals f of x. Then we can rewrite as x squared minus 4 squared over x squared minus 4x. The difference between two squares equals, we can factor a plus b, a minus b. Then back to the original, we can factor x plus 4, x minus 4 over, take out x, then x times x minus 4. Then x minus 4 cancelled, then x plus 4 over x. We can rewrite as 1 plus 4 over x. X cannot be 0 and 4. Then f of 4 equals 1 plus 4 over 4. Then 1 plus 1 equals 2. There is a hole in the graph at 4, 2. The domain is the denominator cannot be 0. That means x cannot be 0 and 4. X-intercept is when y equals 0. That means the numerator equals 0. Then x squared equals 16. Then x equals plus 4 and minus 4. But this one is a reject because of the domain. From here, then x-intercept is minus 4, 0. Y-intercept is when x equals 0, then y equals 0 minus 16 over 0 minus 0, which is minus 16 over 0. That means undefined. So there is no y-intercept. Then f minus x equals minus x squared minus 16 over minus x squared minus 4 minus x. That means x squared minus 16 over x squared plus 4x is not f of x. Also, it's not minus f of x. So, no symmetry. Because f is neither an odd function nor an even function. Horizontal asymptote limit as x approaches infinity. Use this one, x plus 4 over x, then times 1 over x over 1 over x equals limit as x approaches infinity, and expand x over x plus 4 over x over x over x equals limit as x approaches infinity 1 plus 4 over x over 1. Then plug in x is infinity, then 1 plus 4 over infinity over 1 equals 1 plus 0 over 1 equals 1. Do you remember the shortcut? Limit x approaches infinity, x plus 4 over x. When you see infinity over infinity form, then only take the highest degree in each term, which is x over x equals 1. Then we have the same answer. Limit as x approaches minus infinity, x plus 4 over x equals the same. Answer is 1. That means y is 1. Vertical asymptote limit as x approaches 0 from the left, then x plus 4 over x equals, this part is only our thinking. When x equals 0 from the left side, like this, which means 4 over 0 from the left side. This is our thinking. 4 over 0 equals infinity, but negative. And limit as x approaches 0 from the right side, x plus 4 over x equals 0 from the right side plus 4 over 0 from the right side equals 4 over 0 from the right side. This is only our thinking. Equals, this part is infinity and positive. So vertical asymptote is x equals 0. F of x equals 1 plus 4 over x. We can rewrite as 1 plus 4 x to the power of minus 1. Then f prime of x equals 4 times minus x to the power of minus 2. We can rewrite as minus 4 over x squared, which is always negative. That means never be 0. When f prime of x does not exist, x equals 0 from here. But from the domain, x cannot be 0 and 4. So that means there's no critical numbers. There's number line, f prime of x. This is the broken line, 0 and 4, because of the domain. And this one is always negative, like this. F prime of x equals minus 4 x to the power of minus 2. Then f second prime of x equals 8 x to the power of minus 3, which means 8 over x cubed is never be 0. That means there is no inflection point. The number line, f prime of x, the broken line 0 and 4, and f prime of minus 1, this part is 8 over minus 1 cubed equals minus 8. That means negative, concave down. When the testing number is 1, f second prime of 1 equals 8 over 1 cubed equals 8, which is positive. Positive means concave up. When the testing number is 5, f second prime over 5 equals 8 over 5 cubed means 8 over 1 to 5, which is positive, concave up. When x equals 0 is undefined, in vertical asymptote, x equals 4 is also undefined, and 4, 2 is a whole. F prime of x is always negative. F second prime of x is negative, positive, positive. When f prime of x is negative, that means decreasing. Negative is decreasing. F second prime of x is negative. This one is concave down, and positive is concave up. Positive is concave up. The shape of the graph is concave down, then decreasing, like this. Concave up and decreasing. Concave up and decreasing. Then vertical asymptote is x equals 0, horizontal asymptote is y equals 1. When x is less than 0, the shape is like this. X-intercept is minus 4. And between here, the graph is decreasing and concave up. When x equals 4, there is a hole, which is 4, 2. Then this one is y equals x squared minus 16 over x squared minus 4x graph. Number 2, this is the last one. These are cube root, so the inside of the radical can be all real numbers. Then domain is all real numbers. F of x equals, we can rewrite as x to the power of 1 plus 2 over 3 plus 3 times x to the power of 2 over 3, then x times x to the power of 2 over 3 plus 3 times x to the power of 2 over 3. Then we can factor, take out this one, x to the power of 2 over 3, then x plus 3. F of x equals 0. That means x to the power of 2 over 3 times x plus 3 equals 0. And x equals 0 and minus 3. So x-intercept is 0 and minus 3. Y-intercept is when x equals 0 is also 0 because f of 0 equals 0. Limit as x approaches infinity, x to the power of 2 over 3 times x plus 3 equals infinity. Limit as x approaches minus infinity, x to the power of 2 over 3 times x plus 3 is minus infinity. So there is no vertical asymptote, no horizontal asymptote. F prime of x equals 5 over 3 x to the power of 2 over 3 plus 3 times 2 over 3 x to the power of minus 1 over 3. We can rewrite as 5 over 3 x to the power of 2 over 3 plus 3 is cancelled, 2 times x to the power of minus 1 over 3. There is a common factor which is 1 over 3 times x to the power of minus 1 over 3. But if you can't find it, then you can rewrite as 5 over 3 times x to the power of 1 minus 1 over 3 plus 6 over 3 times x to the power of minus 1 over 3. Then you can rewrite as 5 over 3 times x to the power of minus 1 over 3 plus 6 over 3 times x to the power of minus 1 over 3. Then take out the common factor, 1 over 3, then x to the power of minus 1 over 3, then 5x plus 6. Then we can rewrite as 5x plus 6 over 3 times cube root of x. Then f prime of x equals 0. That means 5x plus 6 equals 0. Then x equals minus 6 over 5. F prime of x does not exist. That means denominator equals 0. So these two numbers are critical numbers. That is number line, f prime of x minus 6 over 5 and 0. When the testing number is minus 2, f prime of minus 2 equals, use store key in your calculator, minus 2 store x And write down 5x plus 6 over 3 cube root of x. Enter. You will see this number 1.058 is rounded to, which is positive. When the testing number is x equals minus 1, f prime of minus 1 is rounded to minus 0.333, which is negative. When the testing number is 1, f prime of 1 is rounded to 3.667 is positive. And relative maximum use this. F of minus 6 over 5 is rounded to 2.033, and this part is relative minimum. And f of 0 equals 0. Use this. F second prime of x equals 5 over 3 times 2 over 3 x to the power of minus 1 over 3 plus 2 times minus 1 over 3 x to the power of minus 4 over 3. Then 10 over 9 x to the power of minus 1 over 3 minus 2 over 3 x to the power of minus 4 over 3. Minus 1 over 3 is greater than minus 4 over 3. Then we can rewrite as 10 over 9 times x to the power of 1 minus 4 over 3 minus this one times 3 on each side, 6 over 9, then x to the power of minus 4 over 3 equals 10 over 9 times x to the power of minus 4 over 3 minus 6 over 9 times x to the power of minus 4 over 3. Then we can factor 1 over 9, then x to the power of minus 4 over 3, 10x minus 6. Then we can rewrite as 2 over 9 x to the power of minus 4 over 3 times 5x minus 3. Then finally 2 times 5x minus 3 over 9 times x to the power of 4 over 3. F second prime of x equals 0. That means 2 times 5x minus 3 equals 0. Then 5x equals 3. Then x equals 3 over 5. Then f second prime of x. We already know f prime of x does not exist when x equals 0. And then 3 over 5. When the testing number is x equals minus 1, this part is always positive. We can use only the numerator part, which is this one. Then 5 times minus 1 minus 3 is minus 8, which is negative. Concave down. And the testing number is 1 over 5. 5 times 1 over 5 minus 3 equals 1 minus 3, which is negative. When the testing number equals 1, 5 times 1 minus 3 is 2, which is positive. Concave up. F second prime changes the sign from negative to positive at x equals 3 over 5. So this one is inflection point. Then f of 3 over 5 is rounded to 2.561. Then inflection point is 3 over 5, 2.561. Now we know f prime of x equals 0 when x equals minus 6 over 5. and the undefined. The sign of f prime of x is positive, negative, positive. F second prime of x, undefined when x equals 0, and 0 here. In between the interval, negative, negative, positive. F prime is positive, that means increasing, negative, decreasing, positive, increasing, positive, increasing. F second prime of x is negative, concave down, negative, concave down, negative, concave down, positive, concave up. Relative maximum is minus 6 over 5, 2.033. Relative maximum. Relative minimum is 0.0. Inflection point is 3 over 5, 2.561. Then concave down and increasing this shape, concave down and decreasing, concave down and increasing, concave up, increasing. Then relative maximum, minus 1.2, 2.033. Relative minimum is 0.0. Inflection point is 0.6, 2.561. Until this point is concave down and increasing. Until 0.0, concave down and decreasing. Then concave down and increasing. Then concave up and increasing. Then this is f of x equals x to the power of 5 over 3 plus 3 times x to the power of 2 over 3. I hope this video has been helpful. The previous lesson is linked in the description bar below. If you have any questions, leave them in a comment. Thank you for watching. Please like and subscribe for more.